The Ocean LIDER project, Ocean Renewable Energy Leaders, is an ambitious technology initiative promoted by a consortium of companies with a strong capacity in researching, which addresses the challenges of generating and creating the knowledge and technologies necessary for an efficient and sustainable renewable ocean energy generation. Ocean LIDER total budget was 30 million euros, with a total grant from the Spanish Center for the Development of Industrial Technology, CENIT-E, and the Spanish government's State Fund for Local Investment, the so-called Plan E, along with the backing of the Ministry of Science and Innovation, surely the biggest of this kind worldwide. Ocean LIDER Project Consortium is led by Iberdrola Engineering and Construction, working closely with other 19 companies and 25 research centers and universities that accounts a wide R&D experience. Ocean LIDER project was structured in 6 main areas. Number 1, site characterization. Number 2, ocean renewable energy generation. Number 3, energy distribution, transformation, transportation, and power quality management. Number 4, operation and maintenance. Number 5, marine operations and health and safety. And finally, and number 6, the environmental area, to ensure that all developments are made with sustainable practices. The project pretends to obtain a catalyzing effect through the merging of brand new technologies like wave and tidal generation with a more mature power source that is offshore wind, through its full integration altogether. Combined generation of these power sources will allow to decrease overall production costs, to maximize available development areas through the share of foundations, power support and control and monitoring systems, as well as operation and maintenance activities, creating a new industrial standard. Also, it is expected to apply scale economy procedures to help even further at decreasing overall development and production costs. It is clear that Ocean LIDER is a strategic project for industries like renewable energies, shipbuilding, capital goods manufacturing, and other auxiliaries, because it is expected to create a new market niche that will help to fight against climate change, as well as to create a lot of new employment opportunities. The main target of this video animation is to show the implementation of some of the technologies and methodologies developed in the Ocean LIDER project for the development of a large hybrid marine power plant, including wave, tidal, and wind generation in deep water sites by using floating technologies.
An optimum site selection would be performed through the expert system developed in Ocean LIDER that would allow us to perform a quick site and generation device selection based on different criterions: physical, operational, energy resource, and environmental, whose importance could be established through a decision rule. Results could be managed and represented through a management system and a viewing tool. Sites met ocean characterization would be performed by using this measuring equipment's layout. Wave rider buoys are used to measure wave parameters. Floating LIDAR device is used to measure wind resource. AWAC device is used to measure both currents and waves parameters. A geological characterization would be performed mainly through a geophysical survey performed by an oceanographical vessel towing several equipments to cover the site area. The echo sounder allows us to obtain project site's bathymetry. Both the Geopulse and Chirp Profiler allows us to obtain a seismic profile with more penetration and resolution respectively. Side scan sonar allows us to obtain seabed morphology. During the design phase, the information obtained in previous characterization surveys will be used to perform the detailed design of the main elements of the Ocean Renewable Power Plant. Ocean LIDER project has developed innovative concepts of ocean renewable energy generation devices, a semi-submersible transformer substation, dynamic cables, and connectors. Some of these floating foundation concepts were developed by using a new software tool called Iberdrola FM that is able to perform wind-wave coupled calculations and therefore is able to evaluate simultaneously wind and wave effects, taking into account both structural and seakeeping considerations. A specific software tool was developed allowing to define the optimum redundancy level of the submarine power lines, transformers, switchgear, etc., but also the optimum operations and maintenance needed to maximize power plant's profit. We can define different electrical networks and their level of redundancy and different operation and maintenance plans by defining the human and technical and access means as well as stock management or crew center location. Also, wind and wave data will be used both to calculate power plant's energy yield and operational weather windows. Finally, a lot of simulations could be performed and listed through their IRR and NPV values to assist on choosing the optimum power plant configuration and operation and maintenance strategy. Most of the concepts developed in Ocean Leader were tested in hydrodynamic basins through reduced-scale models to be able to verify the results obtained in numerical simulations performed during the design phase and prior to be manufactured full-scale. During TLP platform and wind turbine tests, operational conditions were simulated by using an aerodynamic turbine that reproduced accurately wind turbines' thrust forces and loads, recording loading and stress data in both the platform and the mooring lines. Also, survival conditions were simulated by testing the concept with waves up to 31 meters in height. Also, towing operations were simulated by creating reduced-scale models of two innovative installation systems, one based in U-shaped barge and another based on using reusable floaters. A current generation turbine based on TLP floating technology was also tested at a reduced scale by Seaplace at Sejipar Basin in Madrid. One of the most relevant results of Ocean Leader project is the dynamic cable test bench, developed by Prysmian, that reproduces real operational conditions of ocean energy generation. Also, Prysmian developed a system that allows remote connectivity of submarine power cables at severe sea conditions. This system was tested successfully at a hydrodynamic basin. Now you will see an animation that shows most of the technologies and concepts developed in Ocean Leader used to develop a large oceanic renewable energy power plant in deep waters. TLP platform final assembly, including also wind turbine and wave energy device assembly, will be performed in a dry dock. Also, a semi-submersible transformer substation will be constructed in a dry dock. A DP vessel will be used to install the mooring lines and suction piles to fix them to the seabed. For this same purpose, ROVs will be used equipped with vacuum pumps. Cable installation will be performed by cable-laying vessels equipped with burial tolos and ROVs, as well as wet mate connectors and dynamic cables to connect to floating devices. To install the semi-submersible transformer ST, firstly the dry dock must be flooded. Then the unit can be towed to the project site area by tugs and then connected to the pre-installed mooring lines and power cables. A similar procedure will be used to install the TLP platform and wind turbine and wave energy device. Once the reusable floaters are attached, the dry dock will be flooded. Then the system will be towed up to open waters where ballast operations will take place to adjust draft values according to the towing operation and then connected to the pre-installed mooring lines and power cables. Once this is completed, the floaters will be released and towed back to port for another installation. Ocean power plant's operation will be monitored and controlled remotely from an external control center.